Uh, Good morning, everyone, and welcome to our micro lecture on the quantum finance. Today we will talk about our chapter 4 on the quantum finance theory, okay, and also the quantum price. Okay. So remember, last week we talked about basic quantum finance theory on the brief history on quantum finance, including the Feynman path integral theory and also on the anharmonic oscillator model. Okay, two basic types. As I mentioned beforehand, what we call the first generation of quantum finance is focused on the Feynman path integral. Okay, mainly by Professor Bach here in Singapore, but now in Europe, as far as I know. And basically, he's based on the path integral theory to model the whole life cycle on the finance. And the most important and basic applications on the quantum finance is using this theory, the path integral theory, on the first interest rate, okay, for the US and the Euro interest in the past 30 years. Okay, in fact, it's quite accurate. But as I mentioned last week, the base problem is because of the complexity of the path integral. Okay, so although technically it's okay, but practically speaking, it's very time consuming and also computation intensive. So there's another model, okay, people in the past over half a century, from the 1940 something to up to now, it's what we call the anharmonic oscillator model. In fact, for our quantum finance, we based on this model, okay, with some new extension and also discovery, so that we come up with this book. So in the last week lecture, okay, we give an overview on the anharmonic models as introductions, and also give you some simple formulation for the quantum finance Schrödinger equations. So today, in today's lecture, we focus on the formulation on the quantum finance Schrödinger equation and tell you how can we derive, okay, these equations, and all those. The most important part, as I can say, is the basic theory on how to derive these important equations and how to make use of it in terms of what we call the quantum price level. Okay, in Chinese, what we call the 量子价位. Okay, using quantum field theory to calculate all those what we call the quantum price as a kind of support and resistance level. So today we focus on that. So first of all, we talk about some basic concept first for the quantum finance theory. Okay, and then we give you the step-by-step, okay, formulation of the whole Schrödinger equations and how to make use of it to calculate the quantum price level QFEL. So is today's main focus. Hopefully we can make use of 1 to 1 and 50 minutes, I think, to complete that part. Okay. So for today, focus on this one problem. If financial market really can exhibit some quantum property, okay, as what we have discussed at the beginning of the course, using the particle wave theory, that's phenomenons, okay, and apply it into the financial market. So how can we do the what we call the mathematicals and also the physical modeling? Okay, and after that, we base on this model to build up the whole mathematical structures. Okay, and then we make use of these mathematical formulation structures we discuss in the next lecture. How to model it into our computer models. So it's a three-step process. So let me start again. So first of all, we have to have some idea first, like the quantum mechanics and quantum field theory models, and try to analog with the financial market. So the first one is the model itself. So how to build a model? So basically, we build the physical model first, okay, in quantum mechanics point of view. And then based on this, we build the mathematical models. And next step, based on these mathematical models, we have to think about how to implement, meaning that to put it into our computer system to do the calculation, of course. So it's a three-step process. So today we focus on the first and second part. So how to analog the financial market using the quantum field theory and quantum mechanics, and how to base on this concept to build the model, and then how to build the basic mathematical formulation, what we call the quantum finance central equation. In short, I call this the QFSE. Okay. So once we build a model, what kind of thing or what kind of entities or element we can achieve? Okay. And to extent, meaning that once we can do so, what kind of thing we can calculate or models? Of course, as I mentioned from time to time in the previous lecture, is one major implementations is to base on it to calculate all those quantized energy level, what we call the quantum price level. And in the coming few lecture, we also can extend it based on this quantum price level to forecast the financial market. So that is the second step. And the first step is based on this to build some computational models, what we call intelligent agents, to do the intelligent trading. So we'll talk about this. It's a three-step process. Okay. So let's start with the beginning part. So the concept. So in quantum finance, we model the whole financial market, what we call the financial instrument, such as the cryptocurrency, such as the forex, just as the financial index, like the Dow Jones. And using the wave particle derivative characteristic, which means in certain extent it can appear as a kind of a particle, what we call the price, or the price index. But as a whole, it is existed as a kind of pattern, as we have mentioned a lot in the MT4 system for the technical analysis. All the time we talk about not a single price, but the overall patterns. So you can see there is a perfect match, of course, especially in finance. Because in finance, all the time when we do the trading, of course, you must be based on the price, right? Or the price level, or the return. But as a whole, when you analyze the market traditionally, in technical analysis, we base on the pattern, the overall patterns. So, of course, there is a direct wave particle analog, right? Just like this, So you can imagine as analog with the quantum field theory and quantum mechanics. So we can imagine, instead of the quantum particles, we are talking about some what we call financial particles, or what I call the quantum finance particle, FP, QFP. Just like the different currency pair, like the euro, the US dollar, and the British pound. So you can imagine they are the quantum price particles and exist in the quantum finance market and are fed with each other. Because each of them will generate a quantum field, right? And then they have different quantum levels. So I'll talk about this. We call this the quantum price level. So it's a direct analog. So by doing this, of course, we can generate, the formulation. So, for example, the Schrödinger equation based on this direct analog. So more important, the motion and also the dynamics of all these financial particle or quantum financial particle, what I call, are the main subject, to their intrinsic quantum field, energy field, and also we call this the quantum price field. And up here, as what you can see, is what we call the price level, in Chinese what we call the Java. So in terms of quantum mechanics, quantum field theory, and quantum finance, we call this the quantum price level, QPL, in financial markets. So you can imagine for every single financial instrument like the pounds, the US, the gold, silver, and oil, each of these you can imagine as a kind of quantum particles. And they generate their own field, and they fluctuate or oscillating, okay, within different energy level. And all this energy level as financial analysts, okay, so you can imagine as a kind of support and resistance. So it is a kind of diagonal law. So from financial perspective, okay, all these quantum price level, in fact, can be considered as a kind of SNR. So remember when we talk about the support and resistance in the technical analysis lectures, okay, these are what we call the imaginary, okay, threshold or boundary, so that the price for a particular currency or particular financial market, they can jump up and down. Okay, so it's a diagonal, of course. Okay, and traditionally we call this SNR. Okay, and using technical analysis, different kind of Chatham method, to locate all these price level, what we call as a kind of SNR. But different is that we've just strictly followed the quantum field theory, in the sense that okay, all this in fact is a kind of energy level. In fact, they're not S or R. It's just some quantized price level, so that the price for a particular index, okay, can be jumped from one to another. So the whole logic. So as discussed in the last lecture, if the dynamics of the motion of all the financial particles found in this physical world are governed by the quantum mechanics and quantum field theory, the whole financial market, more precisely, are the price and index movement of every single time step, can be considered as what we call the collective decision making or conscious of all the participants in the financial market. Of course, as we always say, why the market movement? Because of all those people participating in the market in two directions, right? Buy or sell. Or, of course, it's the first whole, but it doesn't make any effect, right? So normally we talk about the supply and demand, okay, or what we call buy and sell. So in terms of that kind of thing, we can also consider, in certain sense, okay, of the market movement as a kind of collective actions in every single minute or every single second for all these people. So you of course you can think about something like this, okay. So the only problem is how can we model that? Of course, no matter what you think, okay. So all the time is we based on some belief, we build a model, and based on this model, we build some mathematical equation in order to do some calculation. So without that, it's only a theory, right? So all the times we have to do it step by step, okay? From some more abstract theory and thinking to some very actual and solid theory model implementations. Of course, for us, forecast. So, and more important, how to implement this in a logical, sensible, and effective way is the most important concept. So the notion of quantum price. So what is that? So for all of you, okay, even though you are the first time touching the financial market, after a few weeks, okay, and thanks for team, so you all have some ideas. What is the financial market? Especially for the real-time spot trading market, okay, for the MT4. So you have some idea, right? So you know what is the financial market, what is financial patterns, what are the price or index, okay, and how they move. The only thing you don't know is how to predict, of course. So one important analog to financial field theory and the classical quantum field theory is the notion of the financial particle in the quantum finance, the quantum price. So as I always say, quantum price in fact is a very interesting kind of thing, okay, which in some sense has a direct analog to quantum field theory or quantum mechanics, in the sense that just like the potential energies, okay, or just like the gravitational field. So you can not see the field, right? So for example, gravitational, but you see one thing: the weight and the gravity pull. Okay, so many people, including me, we will quantize this quantum gravitational field as some kind of mass and weight, so you can see. So in the same analysis, of course, you can think about something like this. Although we can't see the quantum finance field, but one thing you can see is the thing you see in the market is the every single minute or second the price, and the jumping or dropping of the price, right? So for the financial perspective, we all know that the current price for financial product have not only 1 meaning, have 2 meanings. First, it's not only represent the price value, but also the price level. Which means if we believe in the quantum mechanics, every single moment, the electron in the atom, right, it will exist or resist in a particular energy level. Which means the energy level itself, okay, if you call this an energy level, it have 2 meanings. First is the quantized level you can find the electron. And also, in fact, it's a kind of energy level value itself. So you have two meanings, right? It's the level and also the value of the level. So in finance, it's more easy to understand, right? For every single moment, if you believe in the quantum finance theory, is every second you see the price is situate, okay, in a stable state in the quantized price level. So the price itself is the price itself, of course, is the value, and also the energy level in the stable state. So in other words, in finance, price itself is not only a scalar value, but also represent what we call the intrinsic energies affected by itself, the field, and also by other financial instruments. So what I'm saying is that Forex is a very good example because we all know, okay, if you have some experience in doing the trading in MT4, is every single currency, so for example, the US, the pounds, and also the euro, they are all affecting each other. So in terms of quantum mechanics, okay, or quantum field theory, the energy field, they affect each other. So in other words, for every single financial particle, okay, we can say something like this, okay, the movement of this particle can be visualized by every second you see the market goes. And this is the price. So the price itself has 2 meanings. It's the meaning for the price value or the index value, and also the energy level it can exist. And more importantly, because all the financial market, they are affecting each other. So it is an overall effect for different market affecting that particular financial instrument, like euro or US dollar. So which means as a whole is a collective conscious for every single investor in this particular market. It's just the difference is that you are using quantum field theory or quantum finance to model their phenomena and turn it into a mathematical models. So as an analog to the quantum mechanics and quantum field theory, it's just like the particle exists and influenced by its own quantum potential value and by the other financial instruments or financial field as well. So the truth is the analog of the financial particle in quantum field finance theory using that kind of concept is even more sensible and easy to understand than particles in quantum field. Because the particle in a quantum field is conceptually is sensible, but you can't see, right? You can't see a particle, okay, or even you can't see the energy field, but you can only see the effect. But finance is different, right? You can see the price every time when you open the price financial market using MT4. You can see the price and the overall pattern at the same time. So in some sense, it's more easy to understand than the quantum field theory, the quantum particle in the original concept and theory. That's true. So that's the main reason why more and more people, start to believe in that kind of theory, because you can see. The basic thing is whether you can make profit, from that, or how accurate your, so for example, the quantum price level, by using your own method. But in terms of basic concept, if you believe in the wave particle derivative theory, so it's not difficult to understand or to believe. So next we come across the formulation, the Schrödinger equations. So this time we try to have a step-by-step formulation, and try to tell you why we have that kind of formulations. So recall when we talk about the quantum mechanics and quantum field theory. So for every single particle at position x, in fact, it's a displacement from its what we call the stable state. So as I always say in the last lecture, although it's x, but it's different from the x in Newton's law of motion. Because for Newton's law of motion, the displacement is the displacement from the original position, right, in the whole life cycle. But for quantum particle and the Schrödinger equation, the x is the particle displacement for a particular stable state. So you can imagine it's a kind of oscillator. It's an oscillator, of course, it has a stable state. So x is the displacement. Later on, we will talk about this. So just like this. So the equation, as we go, is from time to time we have two equations, right? The first one is the time-dependent equation with time within the what we call the wave function, right? The second, is the time-independent Schrödinger equations. So as I always say, the time-independent Schrödinger equation is more important in some sense because in terms of finance, every time we take a look on the market for the price, say for example the Dow Jones Index, this price is the instant price. But because according to the quantum field theory, when you see the price, in fact, this price is the stable state at that particular moment after the supply and demand conflicts and bands, right? So in terms of it, what we're interested is the time-independent Schrödinger equations, because what we see from the market, in fact, is the overall effect you can see. And we assume every time, it becomes stabilized. In every single moment. It's a very important concept in finance. So otherwise, there is no way for you to do any modeling calculations. So we call this as a kind of synchronization. So the whole mathematical equation, in fact, will be more simple because when you take away for terms, all it exists is only three parts. First, the wave equations, right? So only have position, no time. The Hamiltonian. So remember, Hamiltonian consists of two parts, Ke and Pe. We will go through it again, don't worry. And also the energy level. In fact, it is a very basic, as you can see, kind of eigenfunction. And all this energy level, in fact, is the eigenvalue, right? And these are the quantized energy level. So the most important part is that when we take away from time, so what it exists is two important things. The Hamiltonian, of course, all the time here. The wave function itself without time. So it becomes a pattern. And also the energy level. So what we are interested, of course, is whether we can base on the whole pattern for a particular financial instrument, to evaluate the energy level. And we believe, this energy level, in fact, is what we call the quantum price level. So there's the whole logic. Of course, the Hamiltonian, consists of two parts, as we have go through it again and again in the past two lectures. The Ke part and also the potential energy part, the Pe part. So first component, Ke, second component, Pe. So how to make use of it? together with the quantum finance model. Quantum finance model. So example, remember in the last lecture we talked about when we try to model the Schrödinger equations. So what kind of entities we want to analog with the x? So in fact, it's the return, right? Because of two reasons. Remember, reason number one is in over 100 of the finance modeling in classical finance, we all believe using the price return is more accurate and more sensible than the price itself. Because all the time you compare with the last figures. So for example, for the daily return. So what we are interested in is not the actual price, is the price proportion as compared with yesterday closing price. So we call it the return. The second is by doing that, it's more easy for you to have a more generic equation. Because when you talk about a particular price, so every single market, the price are totally different, right? But when you talk about the return, if they have the same pattern, so the same formulation can be used. So that's why all in the past 100 years in the classical finance, we are using the R. So same for the quantum finance theory. Because of what? Because as I mentioned beforehand, the X is the Schrödinger equation is not the actual displacement, it's the relative displacement from the what we call stable state. So you can imagine the stable state can be imagined as a kind of the closing price yesterday. If you talk about the daily return, right? So it's more sensible. So by doing that, okay, the whole equation can be replaced X with R. So simple as that. And same for the Hamiltonian and also the time independence Schrödinger equations. So the whole formulation is just a one-to-one mapping, right? Okay, but of course the physical meaning are totally different, right? We are using the price as a kind of thinking for the returns, and also we can imagine, okay, the Planck constant, okay, in many papers, okay, as a kind of uncertainty for the financial behavior, and the mass, okay, will be the intrinsic potential for the financial market. Of course, you can imagine the mass in Schrödinger equation, of course, is analog to the capital. Okay, U is the mass, right, of the market. So because we are the capital market, of course. So physical meaning of the wave function. So we have a very interesting dialogue. Okay, if you are a genius, you know what I'm saying. So in quantum mechanics and quantum field theory, the wave equation itself is the most important component, of course. Okay, without this, okay, we cannot calculate the energy level. So how can we model it, and how can we make the analog? Or what is the wave function? So can we observe it? Can we measure it? Or can we calculate it? So remember, there's a very important phenomenon, right? The double slit experiment. In fact, this is the very thing that triggered me on this quantum field theory calculation. Is for typical quantum particles. So by using the double slit experiment, you will see one thing, right? For some terms, the particle can be exist as the particle movement. Okay, very chaotic. But when you see that as a whole, it will become a pattern. So in fact, the patterns have different meaning in different theory. Okay, in terms of quantum mechanics, of course, is the wave phenomena. Okay, not the particle phenomena. So if it is the wave phenomena, in fact, it is the wave functions that you can see. Because we cannot see the wave function, but we can see the appearance in terms of observations as a whole, not every single particle. Remember, in the double slit experiment, the funny thing is, if you have a detector to detect every single particle, there will not be any wave function. But if you try to observe this as a whole, not every single particle, so as a whole, the whole pattern will be the phenomena of the wave distributions. We call this a PDF, probability density function, in terms of statistical mechanics. Or let's make it more simple. It is the distributed functions, just like the normal function you see in simple statistics. So it's the same case. Say, for example, when you try to take some statistic for a class of students, their exam result, say, for example. So most of the time should be a normal distribution, right? So most of the people will be within the average. Okay, the top guys is the top 5%. Okay, is the tail on the head. Okay, something like this, and fall into a normal distribution. So in terms of statistics, all the times the pattern itself, in fact, is the wave function. But we take about one important thing: the time, because you do the statistic. So you take away the time. Just like when you see the overall big picture for double slit experiment, you take away the time, because you do the experiment and then after a certain time you get the result. As we know, when you try to explore every single particle, you will turn to the Feynman path integral thing, right? So as a whole, okay, you can't see the pattern. So what I'm saying is, okay, the direct analog is you can make use of the overall statistic, which is can be represented as a wave functions or a probability density function. In fact, they are the same thing, but take away the time. So using this method, you can see we can calculate the wave function without time, which means you can only see the overall patterns when you do sufficient experiments. So in terms of finance, what is mean by sufficient experiment is, you are using 1,000 number of training days and see the overall phenomena of the return distributions. One-to-one analog. Perfect. All right. So by doing that, okay, we are using the probability density function in classical statistical mechanics theories. Okay, you take the distribution part. So and take away the time, you can see. So in quantum finance, the wave function can be observed by using similar method, doing the overall statistic or sampling. So in the, as you can see in the lab, okay, in terms of most financial market like the forest, the index, same kind of thing, we have a very long history of record. MT4 provides us by standard is over 2,000. In fact, it's 2,048 trading days. Sufficient. Over 1,000 is sufficient. Okay, so which means for every single financial market, we have the probability density function of the past 2,000 days. So by using this, take away the time. Okay, in fact, the distribution itself is the wave function patterns, right? Which means when you take away this, the whole thing will become a calculation of the probability density function. So we will make use of this, okay, later on by doing the formulation. So it's the first part we have to take a look. So the second part is so when we try to analog the financial market, so what are the key market participants? So by modeling their dynamics or coordinate dynamics, so we can build up, okay, the Schrödinger equations more precisely. So we are doing that. So what are the key pairs in the financial market? Okay, say we are using a very good example is the forest market. So once we have the financial model, next step is the dynamics. So there's all the motion and activity happen inside the model. So how to think about that? So what is the dynamic in the typical financial market? What's the dynamic in the sense that who are the participants? So you can see the whole world investor, of course. But if you're doing so, okay, you can't come up with anything because it's too brief, okay. So you have to characterize all those participants into different types and using mathematical model to model that. So that is what we are going to do. So in other words, what is the major participant in the financial market and what are the behavior, which means the dynamic. So for the biggest financial market, Forex, okay, as I always say, is Forex the biggest OTC of the current market in the whole world finance, okay, and 24 hours, of course, because we have the three region, right? The Asia region from 9 to 4 p.m., the European from 5 p.m. to 8 p.m., and the US time, okay, from our time, Beijing times, from the 9 p.m. to the 3 a.m. So it's the whole world, okay, forex market. It's the biggest one, of course, because it concerns all the currency of the world, the major currency. So in terms of latest finance theory, okay, the key player in the financial market, so for example the forex market, is the market maker. Market maker, in fact, is a very important central part, okay, that control also allow people to participate in the market. Most of the time, they are the bank, okay, and the financial institution. Second one is what we call the arbitrary. Arbitrators are people who try to do some what we call high risk. Okay, is try to do some what we call using the differences in the market, okay, to earn money. We will talk about in details. The speculators, people try to take risks, okay, on the using investment. The investor, the normal people. Normal people all the time, as I always say, is they have some theory behind. First, they believe, okay, in supply and demand. Without this, you can't do anything. And all the time they follow the trend. As I always say in the financial trading course. But also they will know, because every single time when you do investment, there is some risk. So we have some risk control. And lastly, is the most important one, is the hedger. Hedgers are the biggest company and financial institution, and also the bank, okay, that will do some more concern with the protections, or what we call the hedging. We will go through this in details in the chapter number 8, okay. We'll talk about in details. But first, talk about the model first. So from 1 to 1. So market makers. Market makers, okay, is very important. And is the organizations or company, okay, most of the time a financial institution, that provide a platform for people to buy and sell things. Just like a supermarket. The supermarket is a very good example. The supermarket is a marketplace for people to buy and sell things, right? So in U.S. Security and Exchange Committee, okay, SEC, define a market maker as a firm that's then ready to buy and sell stock or any other things, okay, continuous in the sense that you cannot stop people doing so. So which means every time when people want to buy or sell things, you should allow them to do so. So different from stock market, right? Stock market, you have to wait for other parties. So most foreign exchange trading firm or market makers. In fact, there are many. So you have many people ask, okay, there are so many MT4 systems. So they belong to different financial institutions? Yes, that's true. So which means in the whole world, in fact, there are more than 1,000, okay, of trading platform. Say for example, for Forex, they are independent. But the funny thing you may ask is why you can compare. When, say for example, when you have two MT4 systems on two different service providers for the same particular product, all the time the product is the same, right? They can be different, but very, very small. So you might ask, that is an important question. So how can different market, what we call, synchronize? So that's why many people believe in the quantum field theories. The same effect, although there are so many kind of things happen, but all the time when we see things, they are in stable state, what we call, try to stabilize and try to synchronize. So later I will tell you that for all those arbitrageurs, okay, in the old days they trying to make the profit about the difference between different markets. But now it's difficult because you can emerge because of internet. Once the information flowing so fast, it's difficult for you to earn money by differences of a particular kind of financial instrument, say for example the crude oil, to make profit because of the different price. Okay, so the market maker most of the time will allow people to buy and sell things. Okay, just like a supermarket. Okay, and so we call this the market maker. So good thing is by using the market maker theory, okay, all the times it allows people to buy or sell things they want. So they do not need to wait. So of course, market makers have certain kind of risk, right? Because the market changes so fast. Okay, so you may ask, how can they make money? Most of the time, they're using what we call the spread. So as you can see in the MT4 system, all the times, okay, the buying price and the selling price are different. So they make use of the difference to earn money as a kind of handling price or handling charge. Okay, in fact, for some they have some commission, but all the time for the biggest forex traders, okay, like the Forex.com, they don't have the commission. They earn money because of the spread. So you imagine you have the buying and selling price, which one is higher? So market maker also liquidate, provide liquidity to their own market, which means they will try to promote, okay, the market by providing more information to the investors so that they can make trading more easy and provide more information. Okay, so which means to make the market flow. So information is important, of course. Okay, so you can see for most of the MT4 system, they also provide different tools and also different news for the investor to make the decision. The only thing they don't do is tell you how to do that, okay, because it's its own decision. And also in US SEC don't allow you to do so. You can advise, but you cannot, okay, force people to do that, of course. So in terms of investment dynamics, the most major function for the market maker is to maintain the market healthy market movement, okay, liquidity, and also facilitate the efficient absorption of the market buy and selling order, which means all the time it have to sort out, okay, the buy and selling orders all the times, okay, so that people won't get stuck. Okay, as you know, in the major market, okay, even the stock market, when too many people doing trading at the same time, the system will get stuck, of course, because you cannot handle so many transactions at the same time. But technically speaking, it must. Okay, the only thing is in terms of the networks and also the computational limitations, it cannot do so. But theoretically, it must do so, right? So it's two kind of thing, different from the stock, right? Because for the stock, it's different, right? Without the seller buyer, you cannot sell anything. Because the stock market, okay, controller is just a marketplace for people to do the facilitate trading, but they won't absorb the buy and sell orders. Okay, but market maker is different. Market maker, okay, is the organization of the entities that can absorb the buy and sell order. But of course, in order to make it healthy, okay, all those things should be very smooth. Okay, otherwise there will be a very big risk, of course. The second one, the arbitrage. Okay, arbitrage is very common in the past because, as always in the past, information flow is not so fast. So some people will try to make money on the price difference between two or more markets for a particular financial product. Say, for example, gold or silver or oil or something like this. In the old days, we will. Because in those days, we don't have the internet. Okay, all the time, the information flow, especially for the news, are not so fast. So there will be some price difference between different markets for the same financial product. So some people try to make money on this. But as I always say, when the information flow become more and more faster, okay, so in a more efficient market, okay, nowadays it's difficult for them to make money. So imagine from this example is the scenario something like this. Suppose the exchange rate for Euro and USD in Frankfurt market is quoted at 1.25 US dollar. Okay, which means for every single euro you have to pay for 1.25 for 1 US dollar. So hence the euro, okay, and while in the New York, okay, market, it's quoted as 1.3 at the same time. So which means there are some difference. Okay, very big difference in fact you can see. So hence the euro is undervalued in Frankfurt or overvalued in New York, right? So arbitrary, if this happens, will of course explore this imbalance in the price by exchanging the dollars for euro in the Frankfurt market and then exchange in the New York market and making the profit, very big profit, 3%. But of course, you can try, of course, okay, in using MT4. Now it becomes very difficult because the information flow is so fast. All the times when the price fluctuates, all the market will be synchronized very fast. Okay, but in the old days it is very slow because in the old days we don't have that kind of internet, that kind of thing, okay, to facilitate all the information flow and balance all those market differences for the same product. What I'm saying. So the third one is what we call speculator. Okay, speculator is in fact many people are, especially in China and Hong Kong, okay, are speculators. Speculators are risk taker, okay, and all the time, that kind of people will believe in the opposite direction. So, example, when just like the Dow Jones Index now, okay, it dropped by 20%. So all the time, speculator will try to what we call will imagine, okay, market will rebound. So one characteristic of the speculator is they are risk taking. Secondly, he tried to bet, okay, instead of invest on the future movement. And most of the time they are the opposite direction, which means when the trend is going down, okay, all the time they will think they will rebound. Okay, against the market all the time. But not 100%, but all the time, more than 90%, I say. Okay, very common human behavior because the main reason why is something like this because when say for example the Dow Jones drop for more than 10%, so there's only two kind of people, okay, short sell or long buy, right? For all those short sell, of course, they're happy and they go up. But the people all the time when they have a wholesome stock, all the time they'll think, okay, we will buy. The biggest the drop, they think the chance for rebound higher. Okay, that kind of thinking is what we call speculator because that kind of thinking is all the time is not so logical because no one tells you until we have the forecast right. So in finance, speculation is also the practice of engaging risky financial transactions because what they think about it all the time is against the market. Because sometimes they will earn it, but of course not all the time. As I always say, the trend all the time is talk about using the technical analysis, right? It's 75 to 80% correct, which means the risk taker all the time the chance for success is less than 20%, and some people say it's less than 5%. Of course, it depends on your trading skill, right? So in terms of investment behavior, speculators are different from the normal investor in the sense that they don't have any risk control mindset. We will talk about this because we're trying to model that. In other words, there is no damping factor, what we call, against the market volatility. So you can see what is the risk or what is the risk taking. It's because the market volatility, okay, irrational movement or oscillation. So which means for that kind of investors, okay, they have no risk control mindset, which means they have no damping factor on controlling their buying or sell. So we return to this later on. Very funny. So the third type is what we call the hedger. Hedger people is totally opposite. Okay, these people all the time will think about the opposite thing. We call this the hedging. So in China and Hong Kong all the time we have the opposite thinking is the hedger are the risk taking. No, in fact it's not. Hedging is a kind of at the beginning, okay, invent that kind of thing. It's a kind of risk control. So, for example, when you try to buy some stock, okay, in my financial computing course, I always say you can using some counter control, okay, selling some other things. Since, for example, you can say sell the same product, the stock, but using option, or you can sell the stock for similar stock type. So, for example, Pepsi and Coca-Cola, right? GM, General Motors, and BMW. Okay, that sort of thing as a kind of a counterbalance. So we call it hedging. So hedger all the time is that they are more experienced investor. All the time is the fund house. Okay, they try to control the risk by every time taking consideration of the opposite movement. So we call this hedging, and the technique is what we call the hedging technique. We'll talk about this in the coming lectures. Okay, they are very important because in fact all the government, the central bank, all the time they will do hedging. Okay. So the whole attitude or those strategies is what we call the hedging, and the people what we call is the hedger. But all the time they are the financial institution. Okay, but for some, of course, in individual investor, but not the biggest one, of course. The biggest one all the time is the investment bank, the banking institution, the central bank, and so on. Try to make a balance and risk control or on the worldwide financial market. So in other words, in terms of the hedgers, all the time they are hedging. Of course, is making the opposite direction consideration. So it's against the market. So that's why many people also call hedger or call contrarians, because the hedging position all the time, of course, is against the market. It's a kind of risk control. Okay, the else case, right? So, for example, taking a long position in stock and short position on the other stock or the options. So, it's that kind of thing. So, the last one is the normal people, what we call investor. So, investors should be something like this. First, they are financial pattern follower, using the technical analysis, of course, are they. So, the investment all the time is follow the market trend. For example, when it is bull or bear, so the investor will follow the trend once they know the trend. The second is they will have some risk mind, okay, which means they have some risk control. So it can be real estate market, commodity market, stock market, that kind of thing, okay. So the most important thing is to first, an investor all the time is a trend follower. So which means the direction should be the same as the trend of the market. Otherwise, it will be speculator. Okay. Second, they have sense of risk control. So in terms of physical dynamics, they have certain degree of dynamic matter against the market volatility. Which means if the market is more volatile, okay, they will do less. Right? If the market is not so volatile, they will do more. In other words, they will try to regulate the investment behavior according to the market volatility. Right? So we try to model that. So how to do that? Step by step. Okay, first, we are using the excess demand concept. So we already talked about this in the last two lectures, right? So this time we will go through in details. In terms of mathematics, of course. So once we have the key player in the financial market, how can we model their financial dynamics? So excess demand. In fact, remember that excess demand is a very easy concept. In fact, it's that every single moment, second, millisecond, microsecond. Okay, now it might be microsecond because we have the internet so fast. So it is the difference between supply and demand. So as I always say, the most mystery points thing for every single finance market, so for example, the Dow Jones or the Hang Seng Index is how can the price move? You can imagine. Okay, so you can say, for every single change of more than 10 million, okay, net supply or demand, it will change by 1 point. Yeah, something like this. But that magic number, how much, of course, is the magic number? Okay, it's what we call the trade secret in the financial market providers, right? So in terms of mathematics, they are the instantaneous, okay, difference between the supply and demand, which means the buy or sell, okay, in terms of the price, of course, and the volume. So in terms of mathematics, of course, it is differences between the buy or sell, which means when the buy is more than the sell, certain amount, it will go up, otherwise go down. So in terms of mathematics, it should be the change of price by t, right? And the t this time is the every single varies in the small time step, right? So it's dp by dt. P is the price, okay? So the funny thing, of course, the dp by dt, of course, is the r by time. Okay, it's different from the previous one, right? So for very small delta c, so this f, okay, can be approximated by a scaling factor delta. So we will have something like this. So if the time is very small, approximation, which means the rate of change of time at a very small time difference can be the difference of the supply and demand divided by a certain factor. So of course, this factor is the major number, of course, how much it will change by 1 point, right? So we call this gamma, what we call the very important thing, market depth. Market depth. So you can imagine when the market is very big, the gamma will be very big, so that it have to be accumulate more differences. It can change by 1 point. So for a small market, of course, okay, the gamma is smaller. So in other words, okay, in financial jargon is when the gamma is high, which means when the market depth is high, it can absorb more supply or demand in order to change 1 point. Very important concept. So we have something like this. So we do the derivative against del dt will become the second derivative of the price. So it will become 1 gamma dz dt. So the quantitative dynamics for the finance market, according to the investment behavior for the 5 key participants, the main point like this. How can we model the market makers? So the dz by dt, the market maker mm, okay, can be approximated by the alpha positive, z positive, and same for the others. Note that the market maker provides the market facilitative service to absorb all the outstanding excess order. And these alpha are the market absorbability factor. So using the same logic, okay, we're using some approximation. So in terms of the quantum dynamics, basically it's a quantum anharmonic oscillator. Okay, first order, dz dt. That's it. So combined with 8, we will have something like this. So dz by dt will correlate together. So the whole formulation, in fact, is very simple. And of course, it's controlled by the market absorbability factors. It's a kind of proportion. So for efficiency market, okay, the gamma positive equal to gamma negative. So we have something like this. Okay, so it's the formulation for the market maker facilitations. Okay, in terms of the excess demand. Okay, or using something like this and put it into the 4.110. Okay, so you can simplify into the relationship between the delta C first derivative with the return. Okay, so using the simple logic, okay, for the arbitrary funding, as mentioned, in an efficient market, there is the open information, high-speed trading. There's no room for arbitrary trading. So in terms of this, which means there's no room for them to do any kind of interruptions for the market. So they don't have any participations. So for the speculator funding, speculator is always appear to be very important in every financial market. The quantum dynamics using the same formulation, okay, is something like this. But because they have no risk of control, so the quantum dynamic only contain the harmonic oscillator terms, the delta term R, without any high order term. So although the speculator might happen to be trend follower, but most of the time they are opposite. So that's why we put a negative. Okay. In fact, it's true. In every single paper, we prove it in the truth. So more or less the formulation is simple because they have no risk control. So they are no higher order vorticity. Hedgehog. Hedgehog is remember is investor with very high sense of vorticity. Okay. So although they are not always against the trend, but most of the time they are, because they are doing the hedging. So the dynamic is something like this. So you can see the first order term and the second order terms for the because of what? Because this one is the vorticity part. Okay, R squared. No, the quantum behavior for hedges have two terms: the quantum harmonic term, the delta term, and the proportion to R. Okay, and also the market vorticity term, the risk control term, proportion to R second. Investor will similar to the hedge. The only differences is they are the trend follower with risk control. So which means first follow the trend, so it's positive in the first order R, and the negative in second order for the vorticity. So like this. Right. So in fact, this formulation is come across only 10 years before. Okay, on some important papers on the quantum theory, on the quantum finance. So by combining all these equations, so we come up with something like this: the four participators, the market maker MM, the speculators, the hedger HG, and the investor IV. So come with this. So the whole formulation can be simplified into something like this, right? Two terms. The first order term for the what? For the market investment. Okay. So all the time is a damping factor, right? The more you invest, the more control you have, of course. And the second is the vorticity term. Okay. And when we come with this, okay, and then we solve it, this dt being dr dt, in terms of this, so we have damping. So the damping term is this one, and also the vorticity term is that one. Okay, so simple and clear. So we have a more detailed, okay, formulation, so that more closer to get the calculation done. After that, so using the binding price return, as I mentioned, okay, is the certain terms, okay, DRTT is something like this, where M is the mass and the tau is the damping factors, and also the V is the potential factor, remember. So for consistency for the 4.22 and 23, the open damping case where the d squared r dt squared is equal to 0. Okay, which means all the time when you see the market, the over damping is already done. So that damping factors will come into 0. So instead, we will put these two into equal part, right? And then we can formulate the potential part, the dV dr. So and then put it back. Okay, we can have these factors. So quantum dynamics, time-independent quantum dynamics equation will be written into something like this. All come up with the Schrödinger equations. So the most important part is first, the time-independent Schrödinger equations, okay, of a quantum finance contains KE and the PE part. Different from the classical quantum harmonic oscillator, the quantum finance oscillator is the anharmonic oscillator model with two terms, right? The second orders and the fourth order, with corresponding to dynamic factors for the investment. So all the time something like this. What you mean by first order dynamic factor is when you invest more, of course you will control yourself. You can't increasing, right? And the second is the risk of the market, is the natural vibration of the market. It's what we call the volatility, the fourth order term. Okay, and then come up with the wage equations. And then this part is the KE part, right? So although the market is visualized as the price, but the quantum dynamics are controlled by the price return, dP by dt, which is consistent with the classical financial theory. So they are the same story. So the most important part for today's lecture is to talk about how to model, okay, the quantum finance market by using the quantum field theory we learned before. And the most important contribution for this course is how to make use of the current modeling of the financial market to formulate the quantum dynamics by investigating the four different participants, right? The market maker, the investor, the normal investor, what we call, the speculators, the risk takers, and also the hedgehog. And the funny thing is the arbitraries, nowadays no one talk about it because of the information exchange so fast. So all the times it's difficult to make profit on that. So we take out that particular component. So nowadays we only have four basic components, right? And also in this lecture we tell you in details how to get these formulations. Okay. So the next step, okay, is how to make use of this formulation to calculate the energy level, and we call this the quantum price level. So very, very interesting. We're using what we call the finance differences method. Okay, not difficult, but very important and interesting. And of course, you are doing that in the lab as well. Okay, so we stop over there, and next week we will talk about how to make use of the quantum finance Schrödinger equations to calculate the quantum price level. Okay, see you guys next week.